Hey guys, today we will be doing one more example of forces in one dimension. So let's see this example. This is a little complicated one, and this will give you a clear understanding of what the direction of acceleration exactly means. Let's see. We have a mass here of 10 kilograms, which was already moving in this direction with a velocity of 10 meters per second. It was already moving. Suddenly, suddenly there's this guy, or a person puts his finger like this. And because of this finger, there was a force in this direction. Okay. Let's say there was a force in this direction because of this finger, because he's trying to stop it from moving. The velocity is in this direction, it's moving in this direction. But a person puts his finger here, and so actually he's forcing it in this side. He's stopping it, he's trying to stop it. And let's say the force is 20 newtons in this direction. Now let's find out the acceleration of the box. So very simple. In this case, it's just one force. So simply F net is equals to MA. Now in this case, we'll always make an arbitrary axis, remember. But here in this case, because the force is in this direction, it would be intelligent to take this direction as positive and this direction as negative. We could have done it either ways. I've told you we can do it in any manner, as long as we're just staying on this axis, this dimension. It's totally fine whether this is positive or this is positive, but you just have to make an intelligent selection so that your answers do not come in unnecessarily in negative signs. So this is your positive value, and this means that the force is a positive 20 newtons because of this arbitrary axis. So 20 divided by 10 will give you the acceleration. The acceleration would be 2 meters per second square. But we know the acceleration is always in the direction of the resultant force. And in this case, the resultant force was simply this direction. So the velocity is in this direction. It's moving it in this direction. But the acceleration is in this direction. Sorry, 2 meters per second square. This means that although it was moving in this direction, this acceleration is trying to resist the motion. For this velocity, this acceleration is like deceleration, because for this velocity, this acceleration means that every second, because of this acceleration, this constant acceleration, every second there will be a decrease of 2 meters per second, because the directions are in the opposite direction. The signs are in the opposite direction. So this is a negative. So if I right now it's a positive, but if I just turn it around, it would become negative. So this means for this velocity, it's deceleration. Considering this velocity, like taking this in account, this acceleration is simply deceleration, because it's trying to accelerate in the other direction. It's moving in this direction, but this force is making it accelerate in that direction. So what happens is, this becomes a deceleration of 2 meters per second square. So what happens is, every second the acceleration, the velocity decreases by 2 meters per second. So if I just ask you simply, how long will it take, the time, how long will it take for the box to completely come to a stop? You know the acceleration, the deceleration of the box now because of this force. This is the deceleration of the box. All you have to find out is the time taken to bring it to a complete stop. So you know the formula, V minus U over T is equals to A from our previous chapter. Change in velocity divided by time is equals to A. Now we want to make the final velocity 0, because we want to know that the final velocity is 0 for it to come to stop. So we will take the final velocity as 0 and the initial velocity as 10 meters per second. Just substitute and you don't know the time, but you know the acceleration, which is in this case minus 2 meters per second. So now just switch the formula. This becomes minus 10 divided by minus 2. The time becomes 5 seconds. It would take it 5 seconds to come to a complete stop, and the final velocity to become 0 meters per second. So this is a very important concept. It's a very important concept. You can just get confused by the fact that the acceleration and velocity are in different directions. But you have to understand that the acceleration in a different direction means that it is decelerating in this direction. Let's see one more example. I think we would need one more example to just clear things out. Let's see. Here is a box of mass 20 kilograms, and it's already moving at a velocity of 3 meters per second. Now it was moving, and suddenly I just used my finger or just my hand and I pushed it in this direction. It was moving already, but I just pushed it in this direction with a force of, let's say, 40 newtons. And while I was pushing this in this direction, there was a person put his finger in this direction. This was a moving mass, and I just pushed it with a force of 40 newtons, and there was this person who pressed his finger against this mass, and it applied a force of let's say 10 newtons. Now first of all, we'll find out the resultant acceleration of the box because of these two forces. Since there is a force applied, that means there is an acceleration. Let's find out the acceleration. So for acceleration, we know the formula is F is equals to ma, and this shifts as F over m is equals to a. But this m is F net. This is the resultant. So here we'll have to find out the resultant first. Let's see. Let's make our arbitrary axis, and let's just call this one negative and this one positive, because I know I have an idea that or let's just do the opposite thing. Let's just call this one negative and this one positive, because I have an idea that this would be the bigger one, so I don't want my answers to be unnecessarily in negative. So I would just take an intelligent guess here, and I would just make this one positive and this one negative. So what will happen? I'll just sum both of the forces. Just add both of these. You will get this one would be a positive 40, since it's in this direction. So it would be a positive 40, and this would be a negative 10. This would give me a positive 30 newtons, which means in this direction, because a positive sign tells you that it's in this direction. So the resultant force is 30 newtons. Now let's find out the acceleration. The resultant acceleration would be 30 divided by 20. And if you use your calculator, you would get a 1.5 meters per second square. Now the velocity was already in this direction, and the acceleration is also in the direction of the force, which means in this direction. So now you can see, since the velocity is in this direction and the acceleration is in this direction, you can say, since these are both in the same directions, therefore the velocity will increase, it will accelerate. In the previous case, the acceleration was in the opposite direction, so it was to decelerate. It would come to a stop. However, in this case, it will increase its speed. So let's say the question says, when will the box come to a velocity of 10 meters per second? By what time it will come to a velocity of 10 meters per second? So you know your formulas by now. You should remember all these formulas. The formula relating velocity and acceleration is simply v minus u divided by t is equals to a, where v is the final velocity and u is the initial velocity, and t is the time and a is the acceleration. So the initial velocity was 3 meters per second and the final velocity is 10 meters per second. They want to find out the time, and we know the acceleration with which this box is moving. This is 1.5 meters per second square. So let's just substitute 10 minus 3 divided by t is equals to 1.5. Now just switch on the t here and just bring the 1.5 here. Then minus 3 divided by 1.5 gives you t. So t would be, if you use your calculator, this would be 7 divided by 1.5, which would give you 7 divided by 1.5 would give you 4.67 meters per second. So that sorry, since this is time, this would become 4.67 seconds. So you can see that this would increase its speed, since the direction of velocity and acceleration are in the same, they are in the same direction. So it would increase its speed. However, if they are in the opposite direction, considering the velocity, if the acceleration is in the opposite direction as that of the direction of the velocity, then the box or the mass would decelerate. So it would come to a stop eventually. So I hope you understood this concept. If there is any problem, just write it down on the comment section and I will reply to that. And thanks for watching, guys.